Alright, here we go. Can you hear me? Alright, I guess mic's on. Ready to roll. Alright, if it sounds like I'm whispering, it's 6:19 in the morning. Trying to pump this out to you before the day begins. I know 2A doesn't technically start until, third hour? So what is third hour during remote learning? 7:40, around 9. Okay, but some of you like to watch this a little bit early, so I totally get that. Your homework will be out too around 8, 7:38 probably is when I'm going to put it up, is when you should be watching the video. Remember to get this done for attendance. I guess if you're watching this, you already got your attendance, but just make sure. Alright, this is going to be one take thing, mostly because, well, one, it's 6:20 in the morning, and two, this is not one of my favorite lessons that the book has to offer. Just because it has to deal with a lot of stuff that we already know, but now they just put a fancy name on it and then try to confuse you even more. Okay, so let's just get into it. If you guys have any questions, you know I'm available for Zoom. You guys have been utilizing that greatly. Thank you for doing that. I mean, that's why I'm there. I'm there to help you guys. That's why we kind of have a classroom like this, so we don't have to do a mandatory Zoom, so you guys can come in and get individual help, because I think we need more individual help and connection issues and all that more than live Zooms. I think you watching a video is much better as far as connection. Yeah, so I just want you guys to be able to have one-on-one during class time. Or we could all pop in a Zoom, and if I have 5 kids in a Zoom, that's great too. If I ever get to that point this semester, I'll be very happy. Okay, alright, we just have a couple of definitions here. So, let me see if this works. Oh no, stay connected. Thank you. Okay, we're good. Whew, I almost timed out. No, I didn't. I did time out. I did time out. That's tough. No, it says I'm still on. Nope, and I'm gone. Can I get it back? Uh-oh, here we go. Oh, look at me go. That never happens. Alright, sweet. We're good. Yeah, just fast forward out of that part. That never happens. I usually have to restart my whole computer. That's alright. We'll keep moving. Okay, so we have one definition here, 2, 3, 4. Okay, these are all 4 of these definitions you guys have already seen, you guys have already worked with, you guys already know. Okay? So, if k is a 0 of the polynomial function, cool. So we're given a name, k. So the factor x minus k is a factor of the polynomial. Alright? So here's what that's saying. So if I have, I don't know, if I have a polynomial x squared minus 4. Okay, and then we find out 2 is a 0 and so is negative 2. Okay, right? Because what is this factor 2? Difference of 2 squares, right? X minus 2, x plus 2. Okay, and if these equal k, this is going to equal up here x minus k. Alright, so you guys have seen this before. X minus k is the thing we put in parentheses when we factor. We set it equal to 0 and we solve for x to get what our 0 is. You've seen that. You've worked with it. Don't get confused by it. Okay, solution. K is a solution. Okay, we know that. X-intercept, if k is a real number. Okay, remember, real numbers are the ones where it crosses the x-axis. The imaginary is when we don't see it, right? It's imaginary. That's all it's saying. And, like for this example, both of these x-intercepts, if k comma 0 is my x-intercept, be 2 comma 0 and negative 2 comma 0. Okay, you guys have seen that all before. It's not a big deal. NBD, not a big deal. Okay? Now, let's move on. Location principle. Okay, this is something that drives me absolutely bananas. Okay, the location principle, me just saying that probably shuts your brains off. I mean, it'd probably shut my brain off if I was in your shoes, let's be honest. Okay, it's not something confusing. It's not, you should, like, they make it sound like they should get the Nobel Peace Prize for coming up with the location principle. Like, come on, right? It's very, very self-explanatory. It's just a fancy name for it. Okay, the location principle. When you look at a table for a function on your calculator, anytime there is a change from negative to positive, dog, see ya, get out of here. Hey, bye-bye. Negative to positive values, okay? There's a location between the graph, there's a location between where the graph crosses the x-axis. Okay? Alright, so what that is saying, let me show you. It's much better just to show you. Okay, using the location principle to identify the x values that the intercepts will fall between, then find the exact zeros for the function. Okay, yeah, it's saying find the values where but it switches from, and you're looking at your table, where it switches from positive values to negative values. Okay, what does that mean? Here's what it means. Okay, hey, Kelly, see ya, bye. We're not playing right now. We're working. Okay, here's what it means. Here's my normal standard XY chart. Okay, I have an x-axis and I have a y-axis, correct? Everybody agree with that? Okay, down here, now remember, your graph, my x is my input, my y is my output. So when I say I have a negative values for y, that means below the x-axis, that's negative land. Okay, above the x-axis is positive land. Okay, so here's what the location principle says. It's going to say, you're going to look at your table, right? You're going to graph it in your graphing calculator or Desmos. You're going to look at your table and you're going to see where the values switch from positive to negative or negative to positive. What does that mean? Okay, here's what it means. So I'm going to have a normal standard linear function. Okay, standard linear function, no big deal. Okay, so put yourself right about in this area. Alright, where is it coming from? It's coming from negative land, right? It's coming from negative y values, my negative output. Okay, but right about, I don't know if this is 10. Between 0 to 10, we're going to see something where the y values go from negative to positive. Okay, that is the location principle. The location principle says your brain should fire off a alert saying there's a 0 in there. And if your graph does not show it, then you need to manipulate your table in order to find it. Or we could just use our graph to find it. I'll show you how to do that. Okay? We good? Alright, location principle. Don't need a Nobel Peace Prize for it. Very, very simple. Very, very simple. That's one of the things that irks me about math sometimes. We lose you guys before we even start just because we have fancy terms for stuff that doesn't need fancy terms. Alright? Okay, so let's plug this graph into our graphing calculator. Now, should I show you one? Yeah, I have one pulled up. Let me show you one. Okay, this is what I'm talking about. Pay attention here. So, in this top left, and if you want to get to this table, you could plug any function in, just like I did down below. Hit this little wheel, see this little table thing? You can click that to get to any table. Right? So this is what the location principle says. My polynomial is x to the 4th minus 9. Okay? Now, is there anywhere, can we just estimate the zeros? Is there anywhere where we see a 0 for the y value in our chart? No, right? Absolutely not. I see no 0 on the right side of my chart there. Remember, this is my x values, obviously. This is my y values. It's my output. Or you can just put the function. It's another way to put it. Okay? So the location principle says, I'm looking for a change in signs. Negative to positive or positive to negative. Well, between negative 1 and negative 2, okay, I do have a change. what does this mean? Well, I mean, let's try to make sense of it. So -1 and -2 are out here somewhere. So I'm negative for -1, okay? But when I get to -2, I become positive. So do we think there's going to be 0 around there? Yeah, we do. Okay, in between -1 and -2, there's going to be a 0. Why? Because it changes signs. We know it crosses. It was in negative land, now it's in positive land. Okay, does it happen again? It does, right? Between 1, +1, and +2. So +1's right here, +2's right here. I'm going to guess we're going to have a 0 in between. Okay, why can I guess that? Well, we change signs. We know it's got to cross the x-axis. We go from negative to positive. So at +1, we are in negative land. When we go to 2, we are now in positive land. That means something had to cross the x-axis at some point. Alright? You guys think I'm right? Anybody disagree with me? Well, we'll find out. Okay, let's zoom in. What happens? Are we right? Yeah, we are. Okay, that's what the location principle says. That means we can guess. What's the point of guessing if we can just find out? Yeah, I agree. I'm already hearing that from you guys. I totally agree with you. Okay? Notice, we were in negative land, and we go to positive land. Here's going to be my 0. This decimal, nasty looking decimal. We were in negative land, go to positive land. We decided there's going to be a 0 in between 1 and 2. There is, and there it is. Okay? Okay, alright, cool. Alright, now, let's see, do I want to use a graphing calculator for this? And I will show you guys how to pull up a graphing calculator. It's very, very easy. Okay, we want to find the exact zeros of this function here. Okay, we can do that. I already have it plugged in, so let's just use it. That's the hardest part. Alright, so here we go. I'm going to flip it over. It's much easier. I'm just going to be talking for the rest of this one. I might write a little bit, but not too much. Alright, so look. So to pull up a graphing calculator, all you got to do is type in your search bar this up here. Every one of you has a graphing calculator on your computer. So I typed in that function exactly. Alright, what next? So I want to use the location principle, right? So let's go to second table and let's check. Okay, is there any place that you see off the top of your head that has values that go from negative to positive? How many are we seeing? Well, there's one, right? In between -2 and -3. Okay, so let's write that down. So here's my guess. There's going to be 1, -2, and -3. In between there at some point. Okay, is there another one that we see? How many zeros is this supposed to have? Okay, it could potentially have 3, right? Could potentially. Our solutions. Do we see another one? I do. 10 and -6, right? It goes from +10 to -6. So in between what? -1 and 0. So that's going to be my second one. Okay, somewhere in between there. Alright, let's look at the graph. Let's look at the graph. Okay, there's my new graph. Let's zoom out. Ooh, there's another one, isn't there? Let's see. We should have 1, 2, 3. Okay, let's look at the graph and see. Well, we got the one between -2 and -3. So -2 and -3. So we got this one. We got the one in between. Where's one? No, -1 and 0. So we got this one. What about 1 and 2? So now I should look at my graph and get between +1 and +2. Let's scroll down to get positive x values. Boom. We have another one, right? Okay, we have another one between 1 and 2. Good. Okay, so we thought we only had 2. We looked at the graph, realized there's 3. Now we can figure out where it's going to be in between. That totally makes sense. Alright, to find the zeros of the function, you can either use your graphing calculator or use Desmos. Look how easy this is. Ooh, I don't want to click on that one. Let's click on this one. Boom. Those are my zeros. Very, very simple. Okay? Alright, cool. Awesome. That's the first one done. That's location principle. Just taking a guess. Just kind of narrowing in our guess. Alright, we gotta move on. Okay, now we gotta talk about something called turning points. Does turning points actually give you a physical definition? No, not really. Not a clear one. It can tell you how many turning points we could possibly have at most, n minus 1. Okay, your graph can always have n minus 1 at most turning points. Okay, what is n? N is your highest degree. So, for example 1 that we just did, what was the highest degree? Well, it was cubed, right? It's a cubic. Okay, so my degree of my polynomial would be that. At most, underline. Okay, I'm not saying this is exact turning points, I'm just saying at most. It could possibly have n minus 1, 3 minus 1, 3 is going to be my n, 2. I could have at most 2 turning points. What's a turning point? Okay, listen. A turning point is this. Okay, what I say, what I tell everybody every time I've taught this, is turning points are the fun part of the roller coaster. If that makes sense, great. If it doesn't, well, I tried. Okay, what a turning point is, the graph literally turns. So, boom, fun part of the roller coaster, put someone in the roller coaster, and drop down, right? This is a turning point. The graph physically turns. What about down here? It also physically turns down here, too, right? That's called a turning point. Okay? Alright, now another thing. A maximum, this kind of looks like half. Right, if I cut this graph in half, it'd just be a parabola, right? This kind of looks like a max, and this kind of looks like a min. Well, it is. Okay? It is a maximum, and it is a minimum. That's why there's little dots here. Because Desmos says, you know what? I'm going to recognize that as a potential maximum minimum. It is, right? And they put a dot there for you. That's the highest point of the graph, lowest point of the turning points. Alright, it's actually local. Local max, local min. Is it the lowest value of my graph? No. Is it the highest value of my graph? No. This right here goes on forever. But we have local maximum, local minimum at the turning points. Okay? Not too hard. Anytime you have a turning point, you're going to have a max or min. Okay, what else does the note say? Every turning point will either be a maximum or minimum. Local, I wish I had local here. Local max or local min. We can use the graphing calculator to find the coordinates, should just be an S here, of the maximums and minimums as well as the zeros. Yes, we can. Okay, I just did it. I did it in Desmos. Right? It's easy to me. Okay, this is what you put in for your local max. Right here, that's what you put in, and your minimum you would put in this value. Okay, and that's the last line. Okay? Alright, if you want to use a graphing calculator, the old school way, here's how you would do it. I already have it plugged in for you. So once again, I already have the same table plugged in. The pen doesn't like you working on the graphing calculator. Okay, I go to my graph. Okay, I made my window a little larger, so like I went to window, I had the Y min, Y max. Here's why I do that. Look. If you keep it to standard, like -10 and +10, look where you're going to see. Let's go back to the graph. Kind of looks like the top and bottom get cut off, right? Yeah, it does. So my top and bottom kind of get cut off. So what I did is I went to fix the window. Instead of making it negative 10 for the y minimum, made it negative 20, then positive 20. Boom. Okay, we want to hit graph so we can see the turning points. I want to find the max or min. Here's how I do that. So right here is what we saw in Desmos, just super ugly. That's why I hate using these graphing calculators. But they do help. Like in the SAT, you can't pull out Desmos. I wish, maybe someday. Okay, so here's what I want to do. So we know we're going to have a max right here and a turning point. We know we're going to have a min right here and another turning point. Okay, so we want to hit second calculate. Second trace, or the blue is calculate. Okay, we want to find let's do the maximum first. Okay, something's going to pop up on your screen and say left bound and a little X thing. Okay, in order to move this X, you need to move your arrows left or right. Why? It's because it's X values. So X values always go left or right. Okay, so it's attached to your graph. What a left bound means is I want to make a guess. It's trying to hone in the calculator. So you need to give a range to be more accurate for the calculator to hone in. So we're just going to make a little guess here. You want to guess left of where you think the maximum is going to be. So see how the cursor is left of where the maximum is probably going to end up? That's where I want. Hit enter. It should go to right bound. It does. We want to pick a point to the right of it. Okay, closer the better. Boom. Let's see if these two match up. So this is what my graph calculator said. What it does most say. Okay, remember those values. Exactly the same. Which one's easier? Well, you tell me. Alright, next we're going to do a minimum. So same thing, right? Boom, minimum. Now I want to pick a value. So my minimum is going to be somewhere down here. A little bit hard to see. So I want to pick a value left of where I think my minimum is going to be. That's left. Is it close? Not really. Ooh, I definitely don't want to do that. Fat fingers. Okay, is it close? Meh, not really. Let's see what happens. What if I just pick one way far away from it? Okay, and let's do up here, right there, right bound. I'm going to pick a point right of where I think the minimum is going to be. And I'm not even close. Let's see if it messes it up. I'm actually curious. Okay, so here is my graphing kit, my TI-83 or 84, what that tells me, and is it any different? No, it's not. Okay, so does it really matter? Do you have to get really, really close for it to be accurate? No, I just proved it. Okay, what if I want to find a 0 on these calculators? 2, boom. Okay, it's same thing. So I'm looking for zeros. My zero is going to be here and here. This is a little bit harder because your brains can't really wrap around this. So I'm going to be left bound of that 0. Okay, remember my graph goes from left. Is this your right or your left? I don't know. It's my left to my right. Okay, left to right. I read left to right. Okay, so I want to go left bound of where I think the 0 is going to be. I know I'm going to have a 0 here. We already found it out. We already calculated it, but it's okay. Alright, I know I'm going to have a 0 here. So I want to be left of that 0. Alright, I don't want to be above it because the graph is moving left to right. I want to be left of it, but it's also going to be below it. Okay, so it's left bound, boom, enter. Right bound, you want to be above it now because it's moving left to right, enter, done. Is negative 2, 0? We're geniuses. Okay. Alright. A lot of talking. A lot of me talking. I'm sorry. I sound a little tired. 6:45. Talk about, what is this video? 24 minutes? That's not the worst one. Alright. Make sure we're getting that done. Make sure we're signing in for attendance. Make sure you're getting homework into me with work shown. I'm kind of tired of seeing Slater. I don't know, that's the easy way out, and I'm not going to grade Slater for a month. It's a waste of your time, and it's a waste of my time. It's just, if you're going to just do Slater, just don't even do it. Because really, I mean, we're going to get to the point where we're going to be in-person learning next month sometime, guarantee it. And we might be back to full in-person classes with 30 kids. And you all are going to be very behind. behind the use later. There's nothing I can do about it. Nothing I can do about it. Okay? Alright, that's my warning. Good luck. I don't mean to teacher preach you. Alright, I'll see you guys on Wednesday. We'll have another video that come out, and Friday we'll come up with something. I might do a Delta Math, little Delta Math quiz or something to bump your grade. Give you like 3 tries per problem, easy problems. That'll tell me if you guys really understand the material. That won't be on Slater. Promise you that. Okay? Alright, that's it from me. Alright, hope you guys have a good week. Good start to the week. National championship game is on tonight. We'll see if Ohio State even comes close to Bama. We'll see. Big Ten versus SEC. How's that usually worked out? Not very good, right? We'll see. Alright, see you guys.